Hello students, good morning and welcome to your beautiful channel that is 33.physics for you. In this video lecture, we are going to solve example of chapter 8 Gravitation standard 11 from NCERT textbook, and that is unsolved example 8.20, or you can write exercise 8.20. Exercise 8.20. Two stars each of a solar mass, that is 2 into 10 to the power 30 kg. So mass of first star m1, that is equal to m2, and that is equal to, let us write m, which is given as 2 into 10 to the power 30 kg. Remember, solar mass is 2 into 10 to the power 30 kg. Are approaching each other for a head-on collision. When they are at a distance of 10 to the power 9 km, their speeds are negligible. Means, look, here we have one star of mass m1, and let us say here we have another star of mass m2. Both these masses are same, and when they are at a separation of r equal to 10 to the power 9 km, or you can write 10 to the power 12 meter, their speeds are negligible. Means initial speed of this, let us say v1i is 0, and here v2i is also 0. Their initial speeds are negligible, right? So we can easily neglect v1i and v2i. What is the speed when they collide, or what is the speed with which they collide? The radius of each star is 10 to the power 4 km. That is, this radius, let us write capital R, right? This radius capital R is given as, so here you can write small r is 10 to the power 9 km, that is 10 to the power 12 meter, and the radius of each star is 10 to the power 4 km, or you can write 10 to the power 7 meter. In fact, you can write r1 equal to r2 equal to, this is equal to r1 and that is equal to r2. So basically we have to find the speed when they actually collide with each other. First of all, what we are going to do is we are going to find the total energy of this system when they are at a separation of r. So the initial energy, the initial kinetic energy, let us find first. Let us first find kinetic energy. So initial kinetic energy Ki will be equal to K1i plus K2i. Initial kinetic energy of first star and initial kinetic energy of second star. So that is equal to half m1, or you can write m v1i square plus half m v2i square. You can write m1 and m2, but we have written m1 is equal to m2 is equal to m. Now initial velocity can be neglected, so we are considering this as 0 only. So you can say that this initial kinetic energy is 0. Initial kinetic energy is 0. What will be the potential energy? The initial potential energy for this separation will be, the initial potential energy of this system will be, look, for potential energy there should be at least two mass, right? m1 and m2. It is not like that this will have different potential energy and this will have different potential energy. So that will be equal to vi, which is equal to minus g m1 m2 over r. So that is equal to minus g, m1 and m2 both are same, so let me write m square by r, right? Thus the total initial energy, thus the total initial energy will be, let us write EI will be equal to initial kinetic energy plus initial potential energy. This is 0, so you can directly write minus g m square over r. Let this be equation number 1. Now second, we have to find the speed when they actually collide with each other. So when two stars will collide with each other, let us say this is star 1 and this is star 2. When they will collide with each other, the distance between them will be equal to diameter. This is r and this is r. Remember, this is r and this is r. So the distance between them is not 0. Remember, when two stars will collide with each other, that distance between them will not be 0, right? We have to always find distance from their center. So r plus r, distance will be 2r. Let us say their velocities are v1f and v2f. Actually both are having same mass, right? So their v1f and v2f will be same. So let us write simply vf. The velocity when they collide with each other is vf. So the kinetic energy when they collide is kf, let us say final kinetic energy will be equal to half m vf square plus half m vf square. Half plus half will be 1, so this will be equal to m vf square. And potential energy vf will be equal to minus g m1 m2 over r dash, let us say. So this is minus g m square upon 2r, because when they collide with each other the distance between them will be 2r. Let us say this is r dash. So the total potential energy will be the total energy when they collide will be EF, let us say final energy is actually KF plus VF. KF is mv square, so mvf square minus gm square upon 2r. Let this be equation number 2. Now according to law of conservation of energy, look, I am not having space over here, so I am writing ACC. You have to write complete word according, right? So according to law of conservation of energy, initial kinetic energy, let us write initial kinetic energy must always be equal to final kinetic energy. Now what is initial kinetic energy? So from equation 1 you can say that minus g m square over r is equal to mvf square minus g m square over 2r, right? We have to find vf square, so let us make this subject. So mvf square will be equal to, if you take this on other side, it will be plus gm square over 2r minus gm square over r. So you can see, you can take gm square common, so 1 by 2r minus 1 by r, this is mvf square. So 1m will get cancelled out. So therefore vf square will be equal to g is 6.67 into 10 to the power minus 11 into mass of each planet is given as 2 into 10 to each star, sorry, is 2 into 10 to the power 30 kg, 2 into 10 to the power 30 into 1 by 2r, and r is actually 10 to the power 7. So 2 into 10 to the power 7 minus 1 over 10 to the power 12. 10 to the power 12, right? So this will be equal to, let us simplify this, 6.67 into 2 will give you 13.34. 13.34 into 10 to the power 30 minus 11 is 19 into, you can do one thing, you can cross multiply this, or simply you can directly write 1 by 2 is 0.5. So this is 0.5 into 10 to the power minus 7 minus 1 by 12 is 10 to the power minus 12. 10 to the power minus 12. Right. So either you have to convert this into minus 12 or this into minus 7. So this is 13.34 into 10 to the power 19 into, this will convert into minus 12. So we have to add 5. So 1, 2, 3, 4, 5. Into 10 to the power minus 12 minus 10 to the power minus 12, right? You multiply this by 10 to the power 5 and divide by 10 to the power 5. So this will be 10 to the power minus 12 by dividing 10 to the power minus 5. And if you multiply by 10 to the power 5, this will be 50,000. Clear? So 50,000 minus 1. So we'll get 13.34 into 10 to the power 19 into 50,000 minus 1 is 49,999. 49,999 into 10 to the power minus 12. So 49999 minus into 13.34 will give you 666,986.66 into 10 to the power 19 minus 12. 19 minus 12 will be 7, right? 19 minus 12 will be 7. So you have to take square root. So when you are taking square root, power must be even. This is odd. So shift point 1, 2, 3, 4, 5 point you will shift. Then this will be equal to 6.669866 into 10 to the power 1, 2, 3, 4, 5 points. So 7 plus 5 is 12. Take square root of this 6.669866. Square root of that will be 2.5826. This will be equal to 2. This implies that Vf will be equal to 2.58 into 10 to the power 6 meter per second. 2.58 into 10 to the power 6 meter per second. So this will be the velocity of this star when actually they will collide with each other, right? Look, an interesting and important example, quite simple one. What you have to remember, or actually what we have done over here is, we have calculated the energy when they are separated by distance of 10 to the power 12 meter, and then we have calculated total energy when they actually collide with each other, and we have used law of conservation of energy. That is, we know that energy, initial energy and final energy must always be same, right? So here we have considered that initial kinetic energy, here we have considered that initial energy and final energy is always same, right? And then we have calculated. You can do in different way also. Directly you can start with this thing. According to law of conservation of energy, the total energy will be EI equal to EF. Then what is EI? Then here only you can write EI is actually EI is KI plus VI. Then what is KI? KI is 0 and this. So directly you can solve. But in this case, what we have done, we have separately solved for initial and final energy. You can solve it directly also. Okay. Thank you.